Hello everybody, my name is Manuel Minteguiaga. I'm from Uruguay and today I will present our contribution to this Congress of the Romanian Society of Apitherapy, Phytotherapy and Aromatherapy. I will share my screen. Okay, here we are. Okay, the title of my presentation is Phytochemical, Pharmacological and Micromorphological Characterization of the api-medicinal plants Baccharis dracunculifolia, supporting application in api-phyto-aromatherapy. For us, it's a great pleasure to be here to present our work that is from different researchers from Uruguay, from Argentina, and from Brazil. Here's the team that is behind our presentation. Okay, as introduction to the presentation, Baccharis dracunculifolia is a shrub. Here you have an image of the plant. It grows from 2 to 5 meters high, and it flowers in autumn and spring in the southern cone of South America. It presents a particular characteristic that is the dioecism, that is male and female individuals are separated, is not an hermaphrodite plant. The common names of the plants, this plant is Chilca blanca in Spanish or Basora in Portuguese. Distribution is in Brazil, Argentina, Bolivia, Paraguay, and Uruguay. And traditionally, it's considered a medicinal plant to alleviate gastric ailments, has anti-diabetic, diuretic, anti-inflammatory, and vulneratory. It is the source, the botanical source of the Brazilian green propolis. In fact, the bees obtain resin from the young leaves. Here you have, for example, young leaves in the shoots. And the bees obtain from here the resins to elaborate the green propolis. Also, from the leaves are obtained essential oils that are rich in the compounds transneurolidol, that is a chemomarker. This is highly prized by the perfumery, by the particular aromatic notes. We have conducted micromorphology studies of this plant. Okay, here you have, for example, different photographs of the plant. Here you have, for example, the glandular trichomes that are present in the surface of the plant, surface of the plant. Here you have, for example, by electronic microscopy. These glandular trichomes are related to the essential oil biosynthesis and storage. Also, for example, here you have cut from the leaves, and you can see secretory ducts also from the plant. These are also involved in the biosynthesis of essential oils. We have studied all the fundamental tissues of this plant. We obtained that the epidermis is uniseriate and it has a striated cuticle in the leaves and stems. Here you have, for example, the stomata that are anomocytic. That is, here you have another stoma. These are surrounded by regular cells. Okay, the mesophyll of the plants of the leaves are isolateral. That is not here you have almost the same structure between the both sides of the leaves. And interestingly, in the pits of the stems, you can see here crystals of calcium oxalate that is very particular interesting, that are like needles between the cells of the pit. We have studied also the volatile chemistry of the plant in the different regions of the southern cone of South America, both the essential oil as well as the hydrolate. Okay, here you have, for example, a gas chromatography mass spectrometry study of this composition of the essential oil and hydrolate. Here you can see the difference between the chemistry of both extracts. For example, the essential oil is rich in hydrocarbons, and the hydrolate, because its polar nature, is more rich in phenols or also in alcohols. The main compounds are, for example, alpha-pinene, beta-pinene, limonene. And in the case of the hydrolate, also is rich in nerolidol. Both the essential oil and the hydrolate are rich in nerolidol. But we have our results from different plant population we have analyzed in Argentina, Brazil, and Uruguay suggesting our results suggest there is the existence of different chemotype, that is different chemical expression of the plants in their region. Not this only. When we studied a volatile composition all along a year, here you have different months of collection. We found a different pattern angle during the year. For example, during the year, you can see here, okay, a peak, a maximum peak during the winter that is composed by monoterpene hydrocarbons like alpha-pinene, beta-pinene, myrcene, and limonene. Okay, this particular composition, this peak is related with the extreme condition of winter, with temperatures below 0 degrees Celsius in many times. Okay, but the plant is not the same all along the year. You can see here, for example, in the spring, okay, when the plant is flowering, it blooms, it increases the composition of oxygenated monoterpenes like transpinocarbiol and myrtenol, and this is related with the attraction of pollinators, because when the plant is in this condition, needs pollinator. Okay. So we have studied this variability, and the plant is not the same all along the year. Also, we have studied the essential oil composition for male and female individuals, and we have studied it separately. And the conclusion is that the aromas from the Baccharis dracunculifolia male and female individuals are different. This is a very particular behavior, because, for example, as you can see here, different compounds are olfactorily detected only in the male and not in the female. Okay, so you can see here the 10, 11, 12 compounds are most detected in male, while, for example, compounds 10 and 11 are not detected at all in the female. Okay, compounds like transnerolidol and viridifluorol are not detected in the female. This is very interesting. Maybe it could be a correlation with nature, because the plants has both male and female, and the bees need to be seed first, of course, male, to carry on the pollen from the male to the female. So the bees needs to differentiate also the sexes, to know the order of visitation from males to females. So this result suggests this type of behavior in nature. We have also studied the non-volatile chemistry. Okay, here you can see staining of the leaves. All these parts are stained from in black, that with ferric chloride. It means that these parts are rich in polyphenols. In fact, we have studied the polyphenols with HPLC-MS, and we have found different compounds, more than 25 compounds, mainly of caffeoylquinic acids, monocaffeoylquinic acids, and dicaffeoylquinic acids. We also have found different flavonoids like benzene 2 and 7-O-methylluteolin among the compounds from these plants. We have also studied the medicinal properties, so the diuretic and salveretic properties. We have obtained an aqueous extract and the stanolic soluble fraction of the extract, and have tested against with the rats. Okay, we have tested different dosifications, okay, in different periods of time. For example, day 1, day 2, 3, and day 7. And in this condition, at the higher doses of 300 milligrams per kilogram, we found effects, diuretic effects, that is the cumulative urine volume increase compared to the control. And also we have found soluretic effect, that is the extraction of sodium cation and chloride ion increase, so compared to the control. So this means that this plant, the extract of this plant, presents soluretic properties, the extraction of salts from the organism. No signs of toxicity were observed after acute treatment with this extract. The oral median lethal dose was over 2,000 milligrams per kilogram. So this extract is primarily safe. And all these extracts were compared with hydrochlorothiazide, that is a conventional diuretic employed in the clinics. We have also studied snake venom neutralizing properties of the different extracts of Baccharis dracunculifolia. This is very important because ophidian accidents are very promotes injuries and also death in cases of extreme cases in South America, not only in South America but all over the world. We have found that the maceration in ethanol of this plant inhibits the proteolysis, inhibits partially the hemolysis and coagulation that is promoted by the snake venom of this snake, Botulism. So our primary indication is a neutralizing properties of the snake venom. So this plant also display allosteric neutralizing properties. Overall, the available evidence confirms the medicinal potential of Baccharis dracunculifolia and its extracts, allowing us to suggest that such bioactive properties may be preserved in plant-derived bee products such as propolis, honey, etc. Honey, supporting future api-phyto-aromatherapy applications. Okay, finally, I have to thank you for the attention. This is my email. If you can write me, or if you wish to write me, this do not hesitate to do it. Is from South America to the world, and this is our list of reference. Okay, thank you very much.